Hey creator! This 3-part mini-series will go over the 3 transform properties: location, rotation, and scale. In the context of an obstacle course, the transform properties are what you manipulate to create dynamic and engaging gameplay. Let's start by learning about the location property, which describes where in the world a prop lives. It does this with 3-dimensional coordinates. Take a look at the translation gizmo that appears when you go to move a prop. The red line on the gizmo points in the positive X direction, the green line the positive Y direction, and the blue line the positive Z direction. Another video in the Math and UEFN series will go over 3-dimensional coordinates and vectors in more depth. For now, this basic info is all you need. It's important to know that there are 2 different kinds of location values: the relative and world location types. These are related to the 2 different spaces in UEFN, the world space and local space. The world space coordinate system is pretty much the default way you interact with your level. At the center of your level is your origin point, 0 on all axes. A prop's location in world space is its position relative to the origin point. This platform has an absolute or world space location of 128, 0, 0, meaning it is 128 units away from the origin along the positive x-axis. The relative location type is only different from the world location type if a prop has a parent that isn't the level itself. In UEFN, a prop placed into the world is generally alone, with the level as its parent. However, you can attach a prop to another, creating a parent-child relationship. For example, this bigger parent platform and smaller child platform. The parent platform has a world or absolute location of 128, 0, 0. The child platform has an absolute location of 128, 128, 64. Since the parent platform only has the level as its parent, its world and relative locations are the same, both based on its position relative to the origin point. The same is true for the child platform's world location, but notice that its relative location is different. That's because instead of calculating its position relative to the origin, the child platform is checking where it is relative to the parent platform. In this case, the child is 1,280 units to the right and 640 units above the parent. Understanding the 2 location types is key when trying to translate props, especially when using animations. By using animations, you're able to create a smoother experience with more consistent collisions. And you'll avoid the network latency of calling a move function every frame update. Take this move to ease function. The delta location value creates a movement in the local space from the world space locations of the current prop and a target prop. Basically, the cake is saying, I want to go where that prop is, which is 20 units in front of me. Then the animation plays to move the cake 20 units. To learn more about moving props directly or through animations, check out the online documentation or follow this bean to the next video, all about rotation.